Okay, well, we're getting ready for a tour for the Maritime Museum at this present time. That's why when we go aboard, you'll see various signs that depicting the tour route. So again, that's this weekend's event. A little bit about Mr. Ryerson. Mr. Ryerson's grandfather started Ryerson Company, a steel service center in the Chicago area. Mr. Edward L Ryerson rose to be chairman of the board of Ryerson, and in 1935 Ryerson merged with Inland Steel, and he rose to be the president of Ryerson and Inland Steel Company until his retirement in 1953. So again, the namesake, that explains a little bit about who Mr. Ryerson was. The Ryerson family had a connection with steel since the early 1800s.
The original Ryersons came to New York in 1663 and had a forge company out there, and then it moved into the Chicago area in 1842 or so.
Okay, yeah.
It's grown since then.
Yeah, yeah. They're a worldwide steel service center now, so, and the company still continues to operate. Inland Steel was sold to an East Indian, I believe, a couple years ago. It's now called ISPAT. He has all assets of the company. The Ryerson is the only one left with the stack insignia, the Inland Steel stack insignia. So there is no more Inland Steel. It's now ISPAT, and managed by Central Logistics out of Highland, Indiana. So we're all set to go aboard. If you want to follow us aboard. Oh, no running. Oh. Okay, immediately to our right here is the in the caged area is a machine shop capable of repairing anything and everything aboard the ship. The ship is actually a small city. We have no extension cords, no hardware store we can run to when something breaks down, so the engineers are pretty versatile. We have to make things happen sometimes in emergency situations, so this area gets used quite heavily. And coming out here, immediately to the right, alongside of the cage, is the refrigeration units for the galley. We're still using Freon here. And panning to your left, you'll see the upper part of the boilers. These are D-type boilers, 450 psi at 750 degrees superheat. They have they're rated in pounds per hour, and basically what that means is they can evaporate 40,000 pounds of water in 1 hour. That's how boilers are rated, and there's two of them. They burn, they're fired by oil, a number 6 oil. That's the residual oil. We heat that to 230 degrees before we can even pump it. And the area immediately below that is the fireman station, along with a burner, a typical burner laying on the deck. Because the oil is so heavy, we atomize that with steam for better atomization, break up the fuel into smaller particles. And if you want to pan behind you, we're looking at, you can see the signs up for the tour, the after drinking water tank, potable water, 20,000 gallons, and then also immediately in the foreground is the MG sets. We have an electric motor turning 3 DC generators for the mooring winches. The mooring winches are DC powered for more control and torque. The deck engines, or the deck winches, develop about 20,000 pounds of foot-pounds of torque. So there are 6 of those aboard the vessel, and they use a 1-inch steel cable for mooring. So we'll continue you're actually getting the same tour that the people will be getting this weekend. There's the placard depicting the ship when it was built. I know maybe you want to zoom in on that. That's okay, we'll proceed down this ladder. What I'm pointing at right here is a retractable soot blower. Because this fuel, it is a residual fuel, it has a tendency to deposit ash and everything on the boiler tubes, which makes the boilers less efficient. So this retractable unit will go into the boiler, and it's actually a steam lance that will clear all the soot off the tubes and make the boilers run more efficiently. So like I said, we're looking at the operating level in the boiler room right now. This would be the fireman station. He's in charge of the burners, changing and cleaning the boilers. There are 2 burners per boiler. This is a typical burner. If this burner was being pulled right out of the boiler, I'd have to have insulated mitts on because the furnace temperature is probably around 2300 degrees. Okay, we can move around here. We're looking at this ship is with some minor putting back together. This ship could sail, I would say, within a matter of 3 to 4 weeks. So the ship is basically as the crew left it in 1989 when the vessel laid up here. She's all set to go. This is a turbo generator, 650 kW. This also operates on steam, 450 psi and 750 degrees superheat. What we have here is the turbine, which probably turns about 5,000 RPM, the reduction gear that brings it down to 1,200, and then finally the generator that provides all the electrical power for the ship. The ship is fully air conditioned. The big electrical demand aboard this ship are the ballast pumps. We have 4 125 horsepower motors capable of deballasting the vessel in probably 3.5 to 4 hours, and sometimes less. That's predicated. The key thing with an ore carrier is loading the vessel in a timely fashion. The other major concern is when you load the vessel, you have to get rid of the ballast. So that's the reason with the 4 125 horsepower ballast pumps.
On the engine, Dave, is this one of the most powerful of the inland boats? I think it was 99 horsepower.
Well, yeah, it's rated at 9,000 horsepower. It can develop 9,900 horsepower. We call it a typical 10,000 horsepower for all intents and purposes. You're looking at the steam turbine right here. There are 2 parts to a steam turbine. The high pressure side, this arrangement is the throttle arrangement. The owners were very particular on how for aesthetic reasons, you see no steam pipes, which would be typical of another steam installation. You see no throttle linkage. Everything is under deck. So again, we're looking at the high pressure side of the turbine. The turbine is turning, I want to say 9,000 RPM. And actually, a steam turbine is just more or less a sophisticated water wheel. Instead of water, we're turning the wheel with steam. Again, the high temperature, 750 degrees. There's more energy the higher the temperature, and therefore more efficient turbine operation. From the turbine, which is this small part right here, we go back into a reduction gear. This is a double reduction, double helical gear. From 9,000, we go back to the reduction gear, and finally to the shaft RPM. We reduce 9,000 down to 105 shaft RPM. From this point right here, from the end of the reduction gear to the actual propeller is about 40 feet. The shaft diameter is 21 inches, a little over 21 inches. The propeller is a 5-bladed stainless steel configuration. Let's see what else. Okay, the propeller is 20 feet in diameter and has a 14-foot pitch. What that means is for every revolution, the vessel is propelled ahead 14 feet. That's theoretical. That's the way it never works that way because you've got the drag of the ship and other things that are considered in there. So that'll push this vessel along about, I know in the brochure it says about 16 miles an hour, but it will go a little faster than that, given the conditions and the trim of the vessel. So again, that's the responsibility of the captain. When you see a laker going up the lake in ballast, it's usually sitting at a pretty good plane, and that's to get the bow out of the water, because the bow thruster tunnel, it causes a great resistance. So they want to get that bow thruster tunnel out of the water so they can pick up more speed. Again, we're moving forward. This is not the typical configuration for a steamer. Most steamers, the console and the boilers face forward, so when I came aboard here as a third assistant, it was a little bit hard for me to get used to maneuvering the engine and looking aft. But, you know, that's something you just do. Okay, right here is the electrical control cubicle, and this is the load distribution center for the ships. We can either run one generator, parallel two generators, and where I'm standing right now is the operating console. This is the man position and at any given time there's an engineer and an oiler and a day worker, a handyman, that takes care of the operation of the vessel. Again, we have the tachometer here, the ahead throttle, the astern throttle, and virtually all vital information is monitored at this point. This piece of equipment, or this console over here, is the boiler automation console. We can control the boilers, water level in the boilers, its fuel-air ratio, and everything from here. So if you care to back up a little bit, I'll show you this. This is called an engine order telegraph. It was invented by a guy by the name of Chadburn in England to relay messages from the pilot house to the engine room in a timely fashion, or I should say a more ordered fashion. There's a similar device up in the pilot house. The captain, when maneuvering the vessel, the captain is in the front window, and the captain will indicate what he wants the engine to do with the similar piece up in the pilot house. Say if he wanted to go slow ahead, this arrow would move to slow ahead and ring a bell. The engineer on watch here would answer the Chadburn and maneuver the engine accordingly. The captain also has a tachometer up there to see that the engineer is performing the function he desires. There's also a wrong direction alarm on here. If you would happen to turn the engine or move the engine in the wrong direction, that alarms. That's one of the requirements. The American Bureau of Shipping and the United States Coast Guard do surveys on this vessel to make sure the machinery and the hull are kept in good working order. Again, we have a little office here, mostly for the logbook. Any event that happens in the engine room or to the vessel is logged, and the trip is documented through entries in the logbook. Okay, we're looking at the low pressure side of the unit right now. There's two parts to a steam turbine. The high pressure side we saw over here, and the low pressure side. As the steam expands, it takes more room. So a steam turbine is designed to get every bit of useful work out of the steam that's possible. And along that path through the turbine, at various points when no more use can be made of the steam in the turbine, it's extracted. There's three extractions. There's the low pressure, the high pressure, and the intermediate extraction, and that provides different facilities aboard the vessel, such as heating water, running auxiliary equipment, and the big thing is heating the feed water. You don't want to put cold water in a boiler. That's heated to 350 degrees before we inject it into the boiler. The hotter the water, the less thermal shock on the boiler. So I don't want to get into too much detail about that. But again, moving over here, we have an air ejector. This is a condensing unit immediately underneath the low pressure turbine. is that what we call the main condenser. All the steam is condensed back into water. We recycle everything. So there's about 1,300 1-inch tubes in this condenser that runs a thwartship under the unit, and seawater passes through there and condenses all the used steam back into distillate again, condensate, and it's added to the system. Here we have an air ejector to maintain a 28-inch vacuum on the engine. We have an evaporator. We make our own boiler water because there's never a 100% recovery. We have a 10,000-gallon reserve feed tank where the water made in the evaporator is stored. That's in the lower engine room. Right here we have the feed pump. Because the boiler operates at 450 psi, we have to have a pretty sophisticated way of getting that water into the boiler. So here we have a steam-driven feed pump, another little turbine that puts water into the boiler, and this unit is an electric centrifugal pump, feed pump. This is the motor part of it. I think this is a 75 horsepower motor, and the actual pump itself, a multi-stage feed pump.
Dave, the steamer EM Ford, built in 1898, has a quadruple expansion.
Right.
How does that differ?
Well, the difference between an older vessel built in the 1900s and a steam turbine, that's a reciprocating engine. They use saturated steam. That's part of the lubrication that the pistons need to operate efficiently. They also have a lot of moving parts. Very dangerous to work on. The oiler physically has to go into the engine and oil various parts. It's a less sophisticated operation. So, okay, we'll move up this ladder. We're going over to the starboard side. Air compressor, the big thing when you have an automated plant is getting good clean air and dry air. So we pay particular attention to that. This is the control air compressor here with the refrigerated unit on. This other compressor right here is for ship service. You know, whatever the deck department needs in the way of chipping hammers or anything like that is supplied from the compressors in the engine room. We'll move through this way here. This is the chief's office in the engine room. Again, logbooks, records, everything is detailed. There's the paperwork is almost horrendous that we're required to keep. So, again, this is not in a very sea-ready state due to the vessel being laid up here since 1989. This is kind of stuff has just been kind of piled in here. Okay, we're moving up here. If you look forward, you can see the weather tunnel. We'll come back that way on after our tour of the forward end. But anyway, the weather tunnel is probably about 650 feet long, and in inclement weather or during a storm, the captain will order everybody off the deck, and this weather tunnel will be used. On the starboard tunnel is for the captain and the passengers, and the port tunnel is used by the crew. Don't ask me why. That's just one of the rules. Okay, we're up on the spar deck right now, and this would be a typical configuration for the crew's quarters. They're two-man rooms with an adjoining head. Again, it's pretty self-explanatory. Okay, moving out here, and we'll move aft to, we'll go into the chief engineer's office. This is the heart of all the paperwork, and the chief engineer is responsible for all machinery aboard the vessel. So at any given time, I was a chief on the Wilfred Sykes, and at any given moment, whatever happened, call the chief and make something happen. So it's a pretty demanding job. The longer the trips are, the less hectic it is. So this vessel was dedicated to a run from Indiana Harbor, Inland Steel's only steelmaking facility, up to Duluth or Superior and back, which usually took about 7 days for a round trip. So the demands on the crew and the equipment would be less than, say, like on the Wilfred Sykes, the vessel I was on, where sometimes we'd make 3 docks a day. It's a pretty intense on the machinery and the crew. So again, we'll come in here, we'll take a look at the chief's office, and we'll swing around and we'll look at the chief's quarters here. Like corporate America, the more seniority you have and the better room you get. So he's got the corner room with the windows and the best view. Okay, we'll continue to move aft, and on the left you'll see the officer's quarters, the first assistant, and this is pretty typical. These rooms are a little bigger than the average vessel right now, but creature comfort was yeah, there you go. Creature comfort was a concern for the company, or for the builders at the time. So this is the first assistant's room right here. The first assistant works directly under the chief engineer and pretty much is in charge of the operation of the engine room under the direction of the chief engineer. So part of the training for the chief engineer, it is to be chief engineer someday. So if you get with a chief that wants to retire or wants you to take over, the first assistant pretty much runs the show. So, and we like that. Okay, to our left here, we're looking at the upper boiler room. What we see right here is the stack breaching, and immediately underneath that is a device called the air heater. Because we want to make use of as much thermal energy as possible, the stack gas is cooled as it goes up to the stack, and at the same time there's a bank of tubes in this boxy looking area, and that is preheating the incoming air. So it's very important that you try to get the air and the water as hot as possible before it enters the boiler, so you reduce the chance of thermal shock. And that's a desire. You want as much thermal efficiency as possible for saving fuel and just overall operation. The key to a steam plant is making good steam, and that's it's a dedicated effort. The second assistant is in charge of that. Water chemistry is very important. He tests water daily, sometimes twice a day. So again, that's one of the key functions of a steam engineer, is to make sure that you have good steam. If you have good steam, everything else runs fairly well. So, not to say that you don't have trouble, but that lessens the amount. So moving aft, I should bring your attention for the maintenance of the quarters, which are painted annually on a regular steamer. This is a composite. It's not Formica. Do you know what this is, Bob?
I'm not sure, but it's something similar to it. And I know when they built the boat, I think these panels were about $75 a piece, and that's in 1959, right? Okay. So it is very expensive.
Yeah.
I think I recall that as being the number. $75 a sheet.
Okay, as you can see, there's quite a few sheets here, but over the years, this has paid for itself in a maintenance-free operation. You know, and that's, like I said, that goes on yearly on the other vessels, where they have to be scrubbed and painted and maintained. The heads in each room are also stainless steel to reduce the maintenance on that. So.
Yeah, these panels were double-faced, so, that's...
Oh, okay. So
your wall thickness is only about 1 inch.
Okay, so that reduced the considerable weight too, because in a regular joiner, the walls would probably be 3 inches or so, and then stiffened with steel accordingly. Okay, we're on the fantail now, looking aft. We have spare propeller blades. There's 5 stainless steel blades, as I previously explained. Occasionally, when you're maneuvering in ice, or if the captain would back into something and curl the tip of this blade over, or have a blade actually. It has happened that a steamer has lost a blade. We carry these spares. All ships do have spares for such emergencies, and usually it's a shipyard job to change them, but I have experienced that personally, to change a blade, it takes about 12 to 15 hours with all hands turning too. Okay, we're panning to the port side, and what we have right here in the foreground is an incinerator. All garbage and all burnables are collected here and burned daily. Years ago, a lot of stuff went over the side. That mentality has changed. We are more environmental friendly now. I can truthfully say nothing goes over the side anymore. Everything is burned. We keep all recyclable steel. We put those off at the loading port. We have a 40,000 gallon holding tank, so no sewage goes over the side anymore. It's I guess when I started in 1967, we're a lot more conscious of what we're doing to the lake now, and it's pretty much a trend on every Great Lakes steamer, or every Great Lakes vessel, I should say, is to kind of take care of the environment. Immediately to the right here, this is an after steering station. Should the pilot house be disabled, it was not uncommon years ago in the 20s they didn't have a very good way to report the weather, and in a few instances the pilot houses were knocked right off the foundation, thus implementing a regulation to have an after steering station. So that's accomplished through this unit right here. You see a rudder angle indicator, the wheel, and the gyro repeater, and the telephone in the box there, so somebody can convey the messages on how to steer the vessel. To my knowledge, it is used and tested, but we've never had to use it.
Actuated also?
No, that's an electric motor. This actually turns the hydraulic pump. Under normal operating conditions, we have this is a double ram hydraulic system with Sperry control in the pilot house. The steering rams are probably 8 inches in diameter that position the rudder according to the wheel command in the pilot house. But this is actually a pump that, if you have no electrical power, this is an emergency condition, you are actually turning the hydraulic pump by hand. That's not easy. Okay, if you want to step over here and pan the stack, that is stainless steel. Like I said, this is the last vessel to have the inland insignia on it. That was changed sometime in the 70s. They actually took the word inland off and went with the diamond with the I in front of it, or on it. Okay, we're looking at an aluminum lifeboat capable of carrying 50 people. This is a gravity type davit. So you pull a few pins here and the boat will launch itself. You have to have an electric motor to raise it up though. So again, drills are conducted weekly, emergency drills and boat drills. The crew doesn't change too much anymore, but years ago we used to have quite a turnover in crew, so it was very important that everybody learn the life-saving measures aboard the vessel. Excuse me, this is one of them, the firefighting capabilities. We have to be prepared to fight any fire or any emergency aboard the vessel. This vessel is also equipped with a fixed CO2 system in the engine room and in the paint lockers forward and aft. There are 76 100-pound CO2 bottles, and that's a smothering type system commonly used in the marine practice. So there's warnings when that device is sounded. You have about 60 seconds to get out of the engine room, and that's also maintained and tested as part of the ABS and Coast Guard surveys that are conducted aboard every Great Lakes vessel. Right here we're looking at the after cruise rec room. So be careful of the sill there. Pretty self-explanatory. We have a TV, VCR, and on most of the new vessels now they have satellites for TV for the cruise entertainment. This is rather a sedentary life, a very ordered life. It's a 3-watch system. I have a little chart depicting how the crew works up in the pilot house, and we can elaborate on that a little bit more once we get up there. excuse me, this is the upper, this is called a fiddly deck. You'll see the actual stacks going up through the funnel. This area gets to be about 120 in the summertime. I've already changed safety valves on top of the boiler, and I couldn't move. My shoes had melted to the top of the boiler, so just to give you a little idea, while it looks kind of pretty going down the lake, somebody's paying their dues keeping it going. So we're coming around here. We're going into the galley next. There's another sill here. All these doors, by the way, are watertight. They're gasketed and dogged. In the event of a storm, we don't want to take any water on or for any down flooding. So that's a major concern also for the ABS and Coast Guard certification to maintain watertight integrity in all the cabins and hatches. Okay, you'll have to excuse the plastic wrapping. Like I said, this vessel is ready to go. The reefer units are shut down and everything is covered up. When I came aboard the vessel, this was a 6-man operation. We had a chief cook, which is responsible for all the ordering and preparation of the meal. The second cook, under his direction, does all the baking and the salad prep, makes the salads and the prep, and 3 porters. 1 porter was dedicated to taking care of the officers' quarters, mopped and made the beds daily, and the other 2 guys did various tasks up here. Since that time, they've automated this operation. There also, I should back up a little bit, there was a night porter, and if you got off work at midnight or 4 in the morning, that night porter was up here and he'd cook you breakfast or serve you lunch, whatever you wanted. That's gone by the wayside in the 70s and reducing manpower and cost. So we're down to a 3-man operation here. The chief steward, which still is in charge of doing all the cooking and the ordering, and the second cook still doing the prep work and the salads and the baking, and 1 porter. However, with that reduction also comes the prepackaged food. Years ago, the cook would get a side of beef and he'd make his own hamburger, he'd cut his own steak. So there were cost savings that way also, but you had to pay a man to do that. Now we've gone to more or less, not fast food stuff, but the packaged stuff like a normal family would buy it in the grocery store. Bob?
Dave, when you're talking crewing now, when this boat came out, was crew number in the 30s?
There was 37 men aboard this vessel. Yeah, now we're down to, I believe we're down to 27. They've done away with the deck watches. They've done away with the night porter. They've done away with the 3 firemen that would be normally manning, taking care of the boilers in the engine room due to that boiler automation council. And naturally, when you get rid of people, you don't need as many galley people to take care of them, so that reduction was inevitable. So,
and if you get into diesel engines now, the crewing goes down a little further?
Right, yeah. The crewing is dictated by the United States Coast Guard, and it's all related to the safe operation of the vessel. What they deem certain measures have to be implemented, and that's an evaluation done by the Coast Guard. Say if you want to reduce manning, you have to set the criteria, and then you have to prove that it can work with the reduced manning. And they're doing it. It's doing it. Manpower is one of the most expensive things. Next to the crew cost and the fuel, those are the major areas where a company likes to save money. I would say on the average, with the crew of 28, the grocery bill for this vessel will probably run maybe about 10 grand a month, give or take. I don't know. On this vessel, when they carried passengers, it was a lot higher. No expense was paid for made for the passengers. It was they got the royal treatment. If the passengers on this vessel were high-ranking company officials or big steel buyers, so that money they hoped would come back in performance or big steel orders. So we're moving in here to the crew mast. There's food is a big item, and this is one of the events that sailors kind of look forward to. I don't know, more out of necessity or well, how do I want to say this? Something to do. This is kind of in addition to the rec room. This is kind of the social area of the vessel. Is the crew's mess, and there's food here. There's food 24 hours a day on a vessel. It's just a given. everybody pretty much expects to eat whenever they want to. So we're moving into the officers' dining room here. Everybody had their assigned seats in here. Everybody had their assigned seats pretty much everywhere. And when I go aboard a vessel, even today, I ask the steward, where do you want me to sit? Because some of these old timers, they have their territory staked out, and you don't want to sit in their seat. So this was the captain and the chief's table right here. This was the mate's table and the engineer's table. So this is just what I remember from the 80s. And if you wanted to sit at that table with the captain and the chief, you had to be invited. We're moving around here. We're coming back into the galley, and we're going to go into the owner's dining room now. We have to just put that up so nobody gets lost. I set the tour yesterday, and to keep things flowing here. So again, this is about as opulent as you can get for a steamer. This was, like I said, this is a very prestigious boat to get a ride on, especially in the 60s. It was a brand new boat. This is where the entertaining was done. The last night of the vessel was party night. There's no alcohol allowed aboard the vessel. So after the passengers had their cocktails up forward, the captain would bring them back for dinner. And as a crew member, I used to wait for the passengers to leave to get the leftover shrimp cocktail and the baked Alaska. It was quite a festive night for the passengers. So the crew kind of looked forward to party night. We can move out here back on the spar deck. Okay, we're looking into the owner's dining room and the deck adjacent to that. The blocks had owned Inland Steel Company, and it was pretty much the wishes of Mrs. Block on how the passenger quarters and the dining rooms were decorated. And Bob, if you care to add a story about that, because Bob was here when they originally fit this boat out and did the decorating.
Yeah, I can remember that this has since been redecorated somewhat, and the original rug on the floor here was a yellow and green striped rug.
Of course, you have to remember it was 1960, so.
Yeah, but it was yellow and green stripes, about 6-inch wide stripes.
Oh, boy.
I'll never forget it. I just thought it was something real different.
Yeah, talking about the passengers, this was, these blocks were, the crew thought this was next to God. This was the boss coming to take a ride on his boat. So no expense was paid, or spared, I mean, and one day the chief engineer came back. I was standing and watching the engine room, and he said, he's frantic. He says, you have your pickup truck at Indiana Harbor? And I said, yeah. Well, in the passenger quarters, the shower is incorporated in the bathtub, and Mrs. Block somehow got in the shower and closed the door and couldn't get out. Everybody's panicked. We're going to rip out eight bathroom shower doors and buy new ones, like on the spot. And I'm thinking, what? How, everybody calmed down after a while, but that was a pretty tense moment for the captain and the chief engineer. And here's Mrs. Block in the shower and can't get out. So since then, I mean, all the blocks have since passed to their dearly reward. But anyway, you kind of remember the little bits and pieces here and there. So we're moving out on deck, and we're gonna go forward. The fencing you see on the left, the fiberglass fencing, that's for the event. That's one of the Coast Guard things they wanted us to do to prevent anybody from falling over the side. So again, we're looking forward now, and with the hatches here. And Bob, maybe you want to tell us a little about the construction of the deck and the hatches, and actually how all that works.
Well, certainly it was different building this boat in '59 than it is the new ones. We had very limited crane capacity compared to what we had now. They put a double bottom down, and then after we got a couple of them down, they had a speed crane right on top of the deck, which would put the sections on the other side. Our main deck sections were put up in only 24-foot sections because that's all we could lift. I remember at Bay Ship we put up on some boats, they were 128 feet long. So the different cost of building was certainly much more expensive in them days than it was
Yeah.
in present days. So hatch covers are all, even though they're pretty large, are all aluminum, keep the weight down.
There's 18 of them. And that the hatch covers, what we're looking at here, the 18, maintain the watertight integrity of the cargo hold. They're gasketed and clamped down. We'll see that a little bit better when we go up the deck. So we can move down and...
This was a riveted hull, Bob?
No, they have some rivets in here. The only rivets in here are the gunnel bar and there's one seam at the turn of the bilge that's riveted. That's the only rivets that were put in here. It's pretty much all welded. I think the hatch covers, the hatch combings were riveted down. But otherwise, there was a very limited amount of riveting in this boat compared to the previous boats.
You could pan that and come around right there. Those are two of the 6 mooring winches aboard the vessel. We saw the motor controller and the MG set down below, and we have a similar setup up forward. Again, this ship is actually like a small city, actually 2 small cities, because they had their own drinking water and everything that they needed to sustain life up forward except the galley. The passengers had their own little galley up there, but no matter what happened, the forward end guys always had to come back aft to eat. They used to come back a lot. Again, here, those are the winch controls there. The mate on watch would control the mooring of the vessel from that station, so they had to move everything to the rail so he could actually watch what was going on with the winches. So I don't think there really isn't much more to say here except how the winches are, these hatches are secured. This is a typical clamp. This is put together with a dogging wrench. The hatches or the clamps are adjusted here, and these are clamped down here like a pin and fulcrum. So again, this is a watertight hatch. In the event of a storm or any inclement weather, the captain will order every one of these to be dogged, clamped, I should say. In the summertime, in a ballasted condition where the weather is fairly reasonable, he may ask the deck crew, or he may tell the deck crew to clamp every other one or every third one. It's a very labor-intense job. It takes 6 men probably 3 hours to clamp this entire vessel. So again, especially in a nice sunny afternoon, the captain may only require every other hatch or every other clamp to be dogged down. So, Bob?
Dave, when the Edmund Fitzgerald went down, there were several theories of hatch clamps loose, or water getting in the cargo hold through the hatch covers, or the tanks overflow pipes were they?
Well, those had carried away on the due to the storm the vessel was in. Like you say, there's a number of different theories on that. I really don't care to speculate on that, but if you can imagine, what I can truthfully say is, with the experience the captain had, I know that every hatch, every clamp was dogged. Yeah. That's just a given. That's so basic that that's not even a consideration. For this hatch to fail, there would have to be something horrendous happen to the vessel. What you have to keep in mind, from here to the bottom of the cargo hold is about probably 40 feet, and now the vessel is full of ore, and this to ship any significant amount of water in that hole, this hatch would have to be completely gone. So
Leakage wouldn't do it.
Leakage through a hatch wouldn't do it. Carrying away of a ballast vent pipe, these are usually 8 to 10 inch pipes that come up on the deck for overflow purposes. If that would have carried away, I doubt very seriously if they'd have taken enough water on for that to cause a sinking of the vessel. The typical theory is that the vessel grounded in uncharted water or charted water that hadn't been up to date since the 40s. What you have to remember, there was 35-foot seas, so if you're riding a crest, you know, you're going up 35, you have to come down 35. So I don't know, I guess everybody can draw their own conclusions as to what happened. It was a tragic event. I remember that night I was on the LA block and we were anchored below the Sioux in the St. Mary's River, and the captain wanted to anchor, and so we proceeded to do what we do in a normal anchorage. Well, about 20 minutes later, he says, I need the engine right now. Well, it takes a little bit to get that engine ready. And I said, so I call him up, I said, okay, I got her turning. He says, well, we're going to have to run the engine slow ahead probably all night. We can't keep anchorage in the river. That's how hard the wind was blowing. So, you know, we have 2 forward anchors down and turning the engine 30 RPM all night, you know it was blowing. So, I still get the goosebumps. The hatch crane, the hatches are stacked in between here at various points along the vessel. This is a one-man operation, an electric motor driving a hydraulic pump for each wheel. When the vessel was built, it was state-of-the-art. It has since become less of a state-of-art due to the advances in the hydraulic operation that most of the new vessels are coming out with. So again, a real piece of equipment and a real nightmare to work on. Invariably, it would happen about 2 in the morning in the rain when the operator, which stood here and couldn't see the electrical cable, which usually slipped when it was wet, would invariably run it over. So now, we can't get the hatches up. Call the chief, get somebody out here to splice the cord. So it's funny how you remember the little events. Well, what you see here on the deck in the way of mooring lines, because the vessel has been laid up here for so long, we call these winter lines, and at some point in time they must have parted a line or something, and rather than store these on a reel or anything, we just left them lay on the deck for future use. Okay, that stack coming up with the garbage can on top, that's the exhaust for the bow thruster. This bow thruster is a 900 horsepower diesel engine turning a variable propeller, located athwartship in the bow. The captain can use this for controlling the bow, making the dock. It's not very effective over anything over a slow ahead. So again, you see the forward winches. We'll go over here through the port passageway. I should bring your attention to these draft meters right here. A typical operation is the mate on watch will load the vessel. He's responsible for the even distribution of the cargo hold and the draft, which is critical when you're transiting the Sioux locks. You're only allowed to draw, the vessel's only allowed to draw so much water, because there is only so much water. So these are the draft gauges, one forward and one aft. He can tell exactly where the cargo is and what the trim of the vessel is. Over here we have a trim indicator. Right now we got about a ½ an inch port lift, and that's usually because we're tied to the port side. That's typical. Again, the mate's in charge of keeping the ship on an even keel. Sometimes that's a little tricky, but for the most part, these mates are trained in this, and you know, you kind of grow up in keeping the ship trim and on an even keel. We're going into the crew's quarters here on the port side. You'll see a typical crew arrangement of forward, wheelsman, watchman, and deck hands. Okay, watch the sill there. Okay, again, these are 2-man berths with the the maintenance-free bulkheads and stainless steel head. Terrazzo floors, which is, in 1960, this was pretty much unheard of in marine construction. Okay, we'll move over. We'll go this way. We'll get over to the starboard side to the officers' quarters. The second mate was usually in charge of payroll for the vessel, or at least for the forward end. That was another responsibility of the chief engineer, was taking care of the payroll for his crew and keeping track of the hours for the crew. First mate's room here. And okay, we're going up to the pilot house right now. Maybe you want to take a quick walk out on the bow here. We'll come back and go up. Okay, we're on the bow of the ship right now. When the vessel is transiting a river or making a port, they're required to have a watchman in this position, more or less to relay messages to the captain, who's standing in the front window up there. This is I believe a carryover from the days when we didn't have effective radar, and the viewing position from the pilot house wasn't as such as it is today. Again, we're looking at the pilot house up on top, in the passenger quarters, the berthing staterooms on the next level. Now we can go up to the pilot house. Okay, this is where the navigation and the operation of the ship take place. The captain's when maneuvering through a river or making a dock, the captain's position is here in the front window. He has a wheelsman back on the wheel stand. We have everything covered up yet. We plan to take this off for the tour when the museum people get over here. But there's a wheelsman there. At night there's a watchman up here and a mate. So everything is pretty much covered from right here. The captain can pretty much direct what he wants to do with the ship from here. This is I told you about the bow thruster. This is the stick for the bow thruster, the variable pitch propeller. He can move the bow forward, port or starboard. This is the engine order telegraph that we saw in the engine room. Again, he can do everything right from here. He's got the rudder angle indicator, and he's got the RPM and the rudder angle indicator, and also the gyro repeater. Should something fail up here, should this communication link fail, he also has a lever here for a working whistle, and that's a mechanical whistle that's aft, and he can tell it's a very loud whistle, or horn I should say. He can command the engineer to run the engine with the whistle for various signals. I'm looking for the signals, but they're not here. Okay.
Dave, you mentioned the paneling throughout in stainless steel use, all for low maintenance.
Yes.
Take care of things. And I recently had a chance to take a trip with Captain Ward. I believe you sailed with Captain Ward over the years. He's a retired master from Inland Steel.
Yeah.
And he said this is the finest vessel he ever sailed on as far as quality workmanship on it. But the welds are beautiful, and the whole vessel is just the best thing he's ever been on.
Yeah, I'd have to agree with that. I was only on here for 2 years. The company, through seniority and the company's wishes, they pretty much, you work out some kind of agreement as to what vessel you want to go on or what vessel you want to work on. So I chose the Wilfred Sykes, and somebody else has chosen to be chief over here. So. Okay, as I explained before, this is the chart of the working hours and the crew aboard the vessel. The captain is in charge of the vessel. He's responsible for everything that happens to his vessel and aboard his vessel. The first mate stands a 4 to 8 watch. The second mate, the third mate, the wheelsman, the watchman, and the deckhands. Again, there are 3 4-hour watches. So if you're on the 12 to 4, you'd work from midnight to 4 in the morning, then again from noon till 4 in the afternoon. And it's a 24/7. As long as the vessel operates, you are required to stand that watch. All the mates are licensed by the United States Coast Guard. Their license is based on frequency of trips. So when they navigate the St. Mary's River, they're given a blank chart and have to draw on all the navigable hazards and the buoys in that area. The chief engineer is right here in charge of all machinery aboard the ship. First, second, third, 2/3, well, one stands the watch, and the other third takes care of all the deck equipment and all the maintenance that's up forward. 3 oilers and a utility man, the steward, the second cook, and the porter. All the engineers are licensed by the United States Coast Guard, and that license is rated in horsepower. All licenses for this vessel would have to be unlimited horsepower steam. The kids coming out of the academies today have steam and diesel endorsements. We're moving over here.
Dave, could I ask something?
Sure.
Interrupt you when
No problem.
you're talking to crews. This day and age, and improve efficiencies and cost cutting. Some of the fleets have gone to just having a mate in the wheelhouse when they're in open waters underway, and they did away with the wheelsman in open waters. They still has to be on in the rivers.
That's right.
Is Pat doing that too now?
I don't know for sure. I would say eventually they're all working towards that end. The wheelsman is up here on a 4-hour watch. What they want to do, and it's a negotiation thing with the labor unions, is to get the wheelsman, because of the autopilot in the navigation equipment that they have today, GPS and the like, the need for the wheelsman to stand a watch and actually steer the vessel is not needing during open transit in the lake. However, that he would be required to do that making a port or going through a river or at night, where you need the extra set of eyes for the lookout. Okay, if you want to take a look at these charts right here, if you want to get back over here so you can see that, what I have here is a cross-sectional area of the ship. Right here, we have no cargo. This is the cargo hold and the spar deck, which we just came up, and the ballast tanks are loaded. Now, under this particular vessel, there are no ballast tanks under the cargo hold, so these are void. Again, note the freeboard, the amount of exposure between the main deck, the spar deck, and the water. Okay, we're moving over here to a vessel loading in port, and you can see the main concern here is to get the water out in a timely fashion to keep up with the cargo that's coming aboard from a chute. So the loading time for this vessel is probably 3.5 hours. It's to the captain's credit if he can do that in a shorter length of time. This is a very intense time for the crew to get the water out of the vessel, so there's no delay. The cargo can be loaded in the fastest way possible. Okay. Okay, here we have a fully loaded vessel and no ballast. Now you note the freeboard. On this vessel, I think there's maybe about 8 to 12 feet of freeboard from the water level to the main deck, to the gunwale rail, and that's all depicted, through your load line marks. It's a regulatory affair when you load the vessel to a certain depth. So, Bob, you want to add something about this?
Well, yeah, you can see the comparison here of the vessel here. But what I wanted to add is when we built the vessel, the original. This was the first section, and when this was built then a 3,500 speed or 3,900 speed crane was put on top of here and ran back and forth on the deck, so that he could take this section from here and put it up on this side. And eventually, as you got along, then there was a second speed crane added, one working forward, one working aft, making all lifts to the other side of the boat. When the boat got completely built, and the speed crane was disassembled and raised out in pieces. But that's the way it was put. This section over here was picked up from the shore by this crane and put up over here. So it was quite a complicated process because of the limited crane capacity that we worked with at that time. probably a 35, 40-ton crane capacity to a 200-ton crane capacity that we use nowadays when we build a ship. So it was quite different.
As long as you have these up, Dave, question I've been asked over the years, and I think it's the most asked question around here now, is why is the Ryerson sitting here? And it's a straight decker. It's probably the last one of the U.S. flag bulk carrier straight deck that has not been converted to a self-unloader.
Right.
And as I understand it, the vessel's construction doesn't lend itself to be converted to a self-unloader. Slope sides and voids here, and it's just...
Yes. In the 70s, the engineering had been done to convert this to a self-unloader. Unfortunately, at that time, Inland Steel was going through a metamorphosis in their steel building facility at Indiana Harbor, the building of a new blast furnace, and most of the revenue at that time got devoted to that project. They also evaluated the rate of return as to converting this vessel as to what they could do with the return of a new blast furnace. It was unfortunate that the blast furnace won out, but being a steel company, that's where they put their money, because at that time they would contract tonnage from other fleets to get the raw material to Indiana Harbor. So again, you have a vessel carrying in midsummer capacity carrying 27,000 ton. The same amount of crew on a 1,000-footer will haul 60,000 ton. So in the same amount of time at the same speed. So and again, the 1,000-footers are self-unloaders. You'll see them. They have a 250-foot boom on. They depend no shoreside facility to unload the vessel. Where this vessel, you have to have a shoreside ore bridge, several of them, to unload this vessel. And when I said 8-hour minimum, that is the bare minimum, because you're at the mercy of the rig operators. If there's a crew change on the rig, on the ore bridge, that's an hour shot. You know, I've already been in Indiana Harbor unloading this vessel up to 2 days, like 48 hours was fairly common. It doesn't make economical sense for a vessel to be in port that long.
Bob and I took a trip on it in '97, and we were in Indiana Harbor at 24 hours, I believe I noted at the time unloading. And somewhere I read that in the inland fleet, if you ran a vessel from Escanaba to Inland Harbor and back, same carrying capacity as this one, a self-unloader can make 25 extra trips in the course of a season as compared to the Ryerson with the unloading with the bucket.
Yeah.
That's money.
Yep,
that's money.
That's right. Every time, and whenever a boat sits at a dock, you know, that's money not being generated. When I started sailing in '67, there was 400 and some boats on the lakes. We're down currently to 55. That's counting the cement carriers. What happened in the interim is the older ships got scrapped, the ships got bigger, and also the seasons got longer. It was very common in the early years to have your vessel laid up and be home for Christmas. As the fleet decreased, the owners wanted the ship to generate more revenue. The seasons got longer, the winters got shorter. The couple years I was on the Sykes, because we laid up in Sturgeon Bay, the last day of layup and the first day of fit out were 9 days apart. So that was years ago you look forward to like 2 to 3 months off in the wintertime. You know, that doesn't happen anymore. You're lucky to get a month off between fit out and layup. So like I said, I had 9 days. I was off officially 9 days one year. So it's a demanding lifestyle. It's a very unique lifestyle. I mean, if I would elaborate on some of the stuff that goes on here, and you know, it would almost well, it probably could be classed as fiction, but it is true. Some of the stuff that goes on here, very closed society. You're accepted or you're not. The guys that aren't accepted don't make it. You know, like I said, the crew changes are less numerous now because there aren't that many ships anymore. So, all in all, it's I guess like anything in life, it's what you make it. You know, I chose this for a lifestyle. It's been good to me. Like I said, after 28 years, it was time to come home. So, we'll move down now, or do you want to change? You still want to go? Okay. We're moving down into the captain's stateroom, and we'll go across the ship to the captain's quarters. Okay, we are looking aft. So again, we're on the port side of the ship. We're going to thwartship. This is the captain's stateroom, and there is some stuff missing in here. But this is the ship's office, the captain's office. Because he is the captain, he gets he's the guy with the most seniority usually on the ship. Between him and the chief engineer, they get a little extra treatment. So and well deserved. Yeah, they pay their dues to get this far. It normally takes a guy starting out well from third mate to captain. It would usually take, I'd say, between 20, I'd say right around 20 years to get a captain's job, depending on circumstances. If he wanted to move around, it may be a little less. If he wants to stay with one fleet and work his way up, and it's the same with a chief engineer. I got my license in 1971, and I got my chief engineer's license in 1985. You have to spend so much time in a given rank before the Coast Guard will let you write the next test. So by the time you get to be chief engineer and captain, I didn't have any gray hair when I started. So. Okay, we're moving down now. We're going into the passenger quarters, the owner's quarters. Okay, we're on the starboard side of the ship. There are 4 staterooms, each with 2 single berths. If you want to, this is pretty typical. Like I said, it was not uncommon for Mrs. Block to come down and order a complete redecorating of this area to her liking. So no expense was spared when it came to passengers and the big steel buyers. So
That's the room we used to get in.
did you?
Yeah.
Mm-hmm.
Yep.
Also, I failed to mention before, when this vessel carried passengers, they had a dedicated passenger porter. This was all the guy did. And when, as long as I can remember, every season we'd have the same passenger porter, and he carried to the wishes of the passengers. You name it. If the passengers wanted something, he did his best to try to arrange that for them. And he had his own little galley up here also. These are another couple staterooms here, typical as in the past. We're moving over here. We're going aft. Usually what this passenger porter would do, he'd fix them light lunches, breakfast, anything they didn't want to go back aft for, because the main meals were served aft. So that's his little forward galley for the passengers. Okay, we're coming into the salon. We're looking to the port side, card table. On one of the older U.S., to tell you how opulent some of these passenger quarters used to get, on one of the U.S. steel boats, the Governor Miller, they actually had a wood-burning fireplace in the passenger salon. Do you remember?
I remember this.
Yeah. Mm-hmm. Like I said, it was a unique experience for somebody to get invited aboard this vessel. You had to know somebody. You had to be a big steel buyer or a corporate executive.
Dave, as I recall, when we're on the trip, there's a story behind this. Did they daily move something along?
They had magnets.
Okay.
So this is a stainless steel chart depicting the trip. So we're down here in Indiana Harbor where the vessel originated, or the trip originated. This was Inland Steel's only steel-making facility, unlike U.S. Steel or Bethlehem, where they had several different steel-making facilities. All the raw material from the range always wound up in Indiana Harbor. So when you boarded the vessel, you knew you were always going to get off in Indiana Harbor. So we'd come up Lake Michigan and through the straits here and into the St. Mary's River, up on Lake Superior. And for years, this had a dedicated vessel dedicated run to the Burlington Northern Dock in Eloise, Superior, Wisconsin. So again, here's Escanaba. They called on there quite frequently. Port Inland. This is a quarry owned by Inland Steel. Limestone is used in the steel making process to collect the slag. That is the slag. All the impurities in the blast furnace are collected by limestone. So that that was a big commodity that had to be transported down to Indiana Harbor. And again, I think we're up here to Thunder Bay.
Looking at it,
Yep.
you can see the marks. It's just kind of worn in here where the
Yeah.
magnets ran, and
Yeah.
you get over into Lake Huron, Lake Erie.
There's not much.
They didn't make
Yeah,
too
this
many
is this
trips
is
over there.
Toledo over here. Okay, from leaving here to Detour, where you started the river, that was about a day's run. Okay, and depending on traffic in the river, you could transit this in 6 to 8 hours. Whitefish Point, it was a run 12 hours to Marquette, or probably 24 hours to Superior. So the total time of the vessel, like you got aboard the vessel, made the trip to Superior, transiting, you'd be back in Indiana Harbor probably 6 to 7 days. So it was a very nice trip, very peaceful. Going through the river here is very scenic in the summertime, and that's where you see most of the other marine traffic too. So, okay, we're moving down now. We're going back down and down into the dunnage room on our way back aft. That pretty much takes care of everything up forward. Okay, this is called a dunnage room. This is kind of a carryover from the sailing days when everything was stored down below, whatever they needed to operate the ship. On the port side there, you see the 300-pound CO2 bottles for discharging in case of a fire in the paint locker. We're looking at looking aft. We're looking at the electrical control cubicle with the MG sets, the winch controllers, and the gyro compass. The gyro compass is usually placed amidship, and the repeaters are placed at various points, one in the pilot house, one back aft. And I've been on vessels where the old man had a gyro repeater in his room and also a tachometer. So he could kind of, I think there's one on the Alpina. Isn't there a tach and a gyro repeater in the old man's room?
Yes, there is.
Yeah.
Yes, there is.
So we're on the main deck. One thing I'd like to bring to your attention is the berthing area, which is no longer allowed anything below the spar deck. All berthing area on new vessels has to be above the spar deck. So in the old days, it was very common to have your deckhands, because they didn't have much seniority. This is where the entry-level people were berthed down here.
Now, when you had a room up forward here, I understand, I've never done it, but running through the ice
Oh,
was just a nightmare.
running through the ice it'd be like in the worst thunderstorm you've ever heard. I can't describe it. Up forward, you're breaking a trail through the ice. Back aft in the engine room, the propeller, everything that's broken up is sliding back along the vessel and being chewed up by the propeller, so that propeller is continually throwing ice chunks up against that hull. It's just...
I understand it's deafening.
Yeah, and you can go along for a little while and not hear nothing, and all of a sudden, it's beyond description, really. You really have to experience it. And another thing about running in the ice, I never ran in the ice with this vessel, but on the Wilfred Sykes, it was not uncommon to have the whole engine room crew in the engine room trying to keep the plant running. We were making the trip into Little Beatty Knock, heading for Escanaba, and for 12 hours we would back the vessel up probably 2 or 3 miles and put it full ahead to try to break a trail into the dock through the ice. Very labor intensive, very fatiguing on the crew and the machinery. You know, nothing seems to work right, including the crew after a while. So that was my last year. Riley and I were on that together. And that was, we'd come out of the engine, we're stuck, right? So we give up, we're done. Call the Coast Guard. I think him and I went to bed and we slept for about 8 hours straight. That's another thing. You don't really get to sleep too much.
And then with all the noise.
Yeah. You get to sleep. Well, even during the normal operation, say if you're standing a watch, it's 8 hours before you have to go back on watch, so you never get 8 hours sleep. And it's usually, I like to call it, if you can get a good 4 hours sleep between watches, that was pretty good. Just the normal operation of the ship, and pretty much the way it is.
Your running in the ice, though, was good business for the yard.
Yes, it was, yeah.
Invariably, we had you in there for repairs, one sort or
Yeah.
another.
Yeah, it's very, like I said, in the ice, it would be very typical to to curl one of those blades over. You wouldn't think that'd be possible, but, and then when you do that, it throws the shaft and the propeller out of balance, and it would vibrate like you wouldn't believe, so. Okay, that pretty much takes care of that. We're going to go back through the weather tunnel now. Like I said, in a storm or inclement weather, it would be, in a storm, I guess I'll preface that, it would be not uncommon to see the deck awash. Like if you're in a 20-foot sea, the whole deck would be awash, and the old man would order everybody off the deck to use the weather tunnel. And I like to tell the story. I'm looking forward one time through the porthole, and I see the wall of water coming down the deck, and it slams into the after cabin, and I'm going, first you jump back, just a natural, and I'm saying, come on, and eventually the water would subside, and you'd bob up again. But in one particular storm on this vessel, the wall of water, the wave came down the dock, and it just seemed like, man, that's not like anything I've seen before. And it smashed the after cabin so hard, it broke the porthole in the chief engineer's quarters. Actually smashed the glass. That's like 3/4-inch tempered glass. So, yeah, that was a lot of scrambling around during that one.
You got your suppliers up at Alloway in Superior. They got some pictures of a Cleveland Cliffs boat that I swear there's 10 feet of water running across the deck.
Oh, yeah, yeah, green water. Yep, I've got some video of that also. Mm-hmm. Not on this boat, but on the Wilfred Sykes. Okay, we're going back through the weather tunnel. It's kind of uneventful and a little dark. We don't have all the light bulbs changed here yet, but I don't know if you want to keep it running. There's not much to see. Again, we're walking on top of the ballast tanks. As you saw the configuration in the pilot house, this is the main deck of the ship. To my right is the cargo hold, and once we get up here in the light, you'll see the sloping bulkheads, and to my left is not the side of the ship, but the ballast, the side of the ballast tank. So to actually get to the side of the ship is probably maybe another 10, 15 feet to the actual ship side.
Dave, you might want to point out a manhole here of accessibility to the side tanks.
Sure. There's 8 ballast tanks along the side of the ship, port and starboard, and this is the access. This is a watertight hatch. This is opened up to at least every 5 years for surveys to complete it. The vessel is to be dry docked every 5 years. That's an ABS, the Class Society requirement, and the Coast Guard is involved in that. During that 5-year period, every space on the vessel is looked at. All the voids, all the ballast tanks. What we do is we look and assess for damage and make a judgment as to what has to be repaired, what we feel has to be repaired. And the owners are usually with us along with several other surveyors, underwriters, because it does get very expensive. So the owner wants to get the most out of his dry docking and the most bang for his buck. So the vessels are maintained, I would say, to the highest standard possible. That's typical of all Great Lakes ships. That's what I do now. I'm a surveyor for the American Bureau of Shipping. So from operating a ship to coming ashore in '94 and to taking this job with the American Bureau of Shipping, I've experienced both worlds. So.
These are for your ballast gauge system?
Yes. Yeah. These lines run to each ballast tank. We didn't get to the ballast manifold. That's in the lower engine room. It's a 24-valve, 10-inch manifold. The oiler on watch is in charge of ballasting and deballasting the vessel at the command of the engineer on watch or the captain, whatever. We have king gauges down there. Those are mercury operated switches, and these lines can sense the level in the ballast tank. So he can watch 8 gauges on the starboard side and 8 gauges on the port side and adjust the valves and the 4 125 horsepower centrifugal pumps accordingly to keep the vessel trim, and also to keep it what do I want to say? Well, to keep the vessel trim, yeah.
Yeah, to know how much water, amount of water
yeah,
in each tank.
And it reads out in feet. I think these ballast tanks carry 38 feet of water. So
We were out here with the Marquette, Michigan, and they loaded it with the gravity chutes. And I couldn't believe how fast this vessel settled down into the water.
Oh yeah.
Just dropped down. I think a 3-hour loading, was it? Or?
That's very
Yeah,
common.
we were up there.
Yeah. So you see the importance on the older vessel. When I first started, they would have to halt the loading operation because the ballast pumps weren't big enough to keep up. So there again, you're sitting at the dock, you're not producing any revenue, you're waiting to pump the water out so they can load more cargo. So when they built this, they didn't want that to happen. Typically, most ore carriers have 2 similar pumps, like 125 horsepower electric motors for pumping. This one has 4.
Back in the 40s, 50s, I don't know, one of the U.S. steel boats was in Duluth and had the record time for loading. Do you recall hearing anything about
No,
that?
I do remember that, but I can't remember the time or anything.
Like an hour or less than an hour,
Could be.
they opened every chute up and dumped it all in and put it right on the bottom before they get the water out of the ballast tanks and get it back afloat.
Yeah, when you talk about that, it was to the captain's credit. The faster he could get the vessel in and out of port, this was a big deal. There really isn't much a guy can hang his hat on in this business. So if you could do something extraordinary, and one thing was, well, we got the vessel out in record time. We set record tonnage. I made the engine go so fast as an engineer. We were efficient. Any little thing a guy could do to kind of give himself a pat on the back, that's kind of the way it was. Are you still going? Yeah, okay, well, we're back where we started from. That pretty much concludes the tour. Again, thank you for watching the video and putting up with all my ramblings or sea stories. But after 28 years or so, and Bob's got longer than that in the business, you pick up a few stories here and there, so.
I don't think, Dave, we could have picked a better man than you to give us a tour on this boat.
Well, thank you. My heart's in it. I haven't sailed since '94, but there's a lot of personal pride with any sailor that's been with the company for any length of time or with a particular ship. I see that with the younger guys coming aboard. They'll come aboard and it's pretty much a job. Well, they get a half a season in and they really start to dig in and say, hey, this is my home, this is my job. I want to do a good job. It's refreshing to see.
I think there's pride also for the builders of this vessel who, to see it, I'm sure Bob just has a lot of memories, and it's great to see it again.
Yeah, we were fortunate to invite by Lee Barr, who was the owner's rep for many years, at the end, just before my retirement, to be offered a ride on this ship. So we took a trip from Marquette to Indiana Harbor and back to Marquette. It was quite a pleasure. So after 47 years in the shipyards, it was It was a great ride because we had spent many hours building it, working on it, repairing it, servicing it for 5-year inspections over the years. So it was a pleasure.
When you stay in the owner's quarters, you feel like a king in the
Right. Absolutely. Absolutely. We were treated like kings too.
we were.
Yes, we were.
My wife and your wife probably never forgot it. There's something else that happens mysteriously when you're a passenger on one of these vessels. You can come on for 5 days or 8 or 10 on some of them. You can take a big long trip, but invariably you get off and you weigh 6 or 7 pounds more than what you were when you got on. The food is out of this world.
Yeah, another thing, you know, like for a sailor, that's another kind of a thing a young guy will go through when he gets aboard. He can't get enough to eat. He's in the galley and, man, this is heaven, you know. And the next thing you know, oh, geez, oh, I ate too much. Well, pretty soon, like when I sailed, I ate 1 meal a day, but I had this terrible habit of grazing. But, and since I've been ashore, I did put on about 10 pounds, but you can see the steps involved here. You know, on any given day, it would be not uncommon for any engineer to climb these ladders several dozen times, just as a way of operating, and it's not even thought about. That's just what you have to do the job. So.
And that's exercise. As a passenger, you don't do much exercise in the day. I just took a trip with Riley Ward on the Alpena. I was on it for 9 days. Alpena, Milwaukee, Waukegan, Alpena, South Chicago, Alpena. And I put on in 9 days. I only missed 1 meal.
Yeah. So, well, again, I think that pretty much concludes the tour. I want to thank you and hope you have a good picture of what shipboard life is aboard a vessel like this, because this is the last of its kind.